Hello friends, I welcome you in lecture number 9 on Poisson probability distribution. In this lecture we are going to discuss one question which was asked in summer 2021 GTU examination. So let's try to understand what is this question. It is given that a car hire firm has two cars which it hires out day by day. The number of demands for a car on each day is distributed as Poisson random variable or Poisson distribution with mean mu equal to 1.5. Calculate the proportion of days on which neither car is used and the proportion of days on which some demand is refused. So here it is given that some car hire firm has two cars which it hires out day by day, and the number of demands for a car on each day is distributed as Poisson random variable or Poisson distribution. So first we define that random variable capital X is the number of demands for a car on each day. The number of demands for a car on each day, and this X is a Poisson random variable with average number of demands is given as 1.5. So the mean of this Poisson random variable is given as mu equal to 1.5, that is average number of demands for a car on each day is 1.5. So we are writing this information. The number of demands for a car on each day is distributed as Poisson distribution with mean mu equal to 1.5. So here X is a Poisson random variable with mean mu equal to 1.5. We are using lambda notation for mean. In this question they have used this notation mu. So both the notations are valid. We can use lambda as well as mu for the mean of Poisson distribution. Now since X is a Poisson random variable, the probability mass function of X is given by probability that capital X equal to small x equal to e raised to minus lambda, but here we are using mu in place of lambda. So e raised to minus lambda, that is e raised to minus mu, lambda raised to x, that is mu raised to x, divided by x factorial, and possibilities for x are 0, 1, 2, 3 and so on. So this small x is the number of demands for a car on each day, because capital X is the number of demands for a car on each day. So the possible values of random variable are 0, 1, 2, 3 and so on. So this gives us the probability of x demands for a car on each day. Now we see what is being asked. Before that we substitute mu equal to 1.5. So therefore probability that there will be x demands for a car on each day is given by e raised to minus 1.5 to the power x divided by x factorial, where the number of demands for a car can be 0, 1, 2, 3 and so on. And we will keep in mind that this car hire firm has only two cars which it hires out day by day. Now we are asked to find out the proportion of days on which neither car is used. So the neither car is used means there will not be any demand on that particular day. So there will be 0 demands for a car on that day, and we are asked to find the proportion of days on which neither car is used, that is equivalent to the probability that there will be no car used or probability that there will be 0 demands on that particular day. Okay, so we can write that the proportion of days on which neither car is used, that means 0 car is used. This is nothing but probability of 0 car, that means there is no demand for car on that day. There is no demand for a car. That means value of small x is 0, or we can say that there will be 0 demand for a car, or the number of demands for a car is 0, or we can simply write probability of 0 demand for a car. And we have the formula for probability of x demands. So in this formula we substitute x equal to 0 and we obtain this is going to be e raised to minus 1.5 to the power 0 over 0 factorial. This is going to be 1, 0 factorial is also 1, so we have e raised to minus 1.5, and if you use scientific calculator you have 0.22313 up to 5 decimal places. So the proportion of days on which neither car is used, that is proportion of days on which there is 0 car is used, is nothing but probability of 0 demand, and it turns out to be 0.22313 up to 5 decimal places. Now in second part we are asked to find out proportion of days on which neither car is used. This we have calculated. Now we find the proportion of days on which some demand is refused. So demand will be refused if demand is greater than 2, because we have only 2 cars. So if demand for a car is more than 2, if there are 3 demands for a car, or if there are 4 demands, so if number of demands is strictly greater than 2, then that demand will be refused because this firm has only 2 cars. So the proportion of days on which some demand is refused is nothing but probability that there will be more than 2 demands. So this also we can calculate using formula of probability mass function. So the proportion of days on which some demand is refused, some demand is refused is equivalent to the probability that the number of demands for a car is more than 2. That is equivalent to the probability of this event capital X is greater than 2. And we can use the concept of complementary event. This we can rewrite it 1 minus probability that X is less than or equal to 2, because we know that X is greater than 2 and X is less than or equal to 2 are complementary events. So the sum of their probabilities must be 1. So now this is nothing but probability, sum of probability starting from 0 up to 2. So this we can calculate. All these probabilities can be calculated using this formula. We put x equal to 0, 1, 2 respectively in this formula. So 1.5 raised to x over x factorial e raised to minus 1.5 can be taken common, but first we write all this 1.5 raised to 0 over 0 factorial plus e raised to minus 1.5 here we have small x equal to 1, so 1.5 raised to 1 over 1 factorial, and e raised to minus 1.5 to the power 2 divided by 2 factorial. So in each term we can take e raised to minus 1.5 common. This is 1, this is also 1, plus 1.5 raised to 1 factorial has value 1, plus 1.5 whole square divided by 2. So we can again rewrite this as, I can write this as 2.5, and if I use scientific calculator, so this I get as 1.125 up to 3 decimal places, and if you simplify all these things, answer will be 0.1912. So this is the probability that there will be refusion of demands, or their proportion of days on which some demand is refused is 0.1912. Now if you don't want to go for these calculations, you can calculate this using cumulative Poisson probability table also. So we use cumulative Poisson table to calculate probability of this event, probability that capital X is less than or equal to 2. So we are interested in this cumulative probability that capital X is less than or equal to 2, and in our case mean is 1.5. They have used alpha to denote mean, so we have to search for alpha equal to 1.5. This is value of small x, it is 2, so we consider small x equal to 2, and we consider this row corresponding to small x equal to 2 and this column corresponding to 1.5, and we find out what is the value at their intersection. Okay, so we can see the value at the intersection of these two is nothing but 0.8088. So this probability is 0.8088. So using cumulative Poisson probability table, we are able to write down this probability directly. So instead of going in this way, you can use that cumulative Poisson probability table and you can write directly. Okay, using probability table also, using Poisson probability table. So probability that demand is more than 2 is nothing but 1 minus probability that capital X is less than or equal to 2, and this we obtained as 0.8088. So that we can write here 0.8088 using Poisson table for mean equal to 1.5 and value of x equal to 2, and we obtain the same answer 0.1912. Okay, so this will minimize the number of calculations. Here we have to just do this calculation if we are using cumulative Poisson probability table. Okay, so in this way you can solve this type of problems, or you can answer this type of questions. Here already they have given that this is the problem of Poisson distribution, so all you have to remember is the probability mass function of Poisson distribution, and you can answer the required probabilities. Okay, so this is all about this session. I hope you like it. Thank you very much.